Selamat sejahtera. I would like to present our lab report flow measurement. There are 4 members in my team, Yiling, Alif, Husna, and me, Manchong. Introduction. The objective of this experiment is to compare the discharge coefficient of different types of flow measurement methods. The theory that had been used in this experiment is the Bernoulli principle. Bernoulli principle states that the higher velocity will result in a lower pressure. In this experiment, there are 3 devices being used, which are orifice plate, nozzle, and venturi. Next, for methodology, the apparatus used in this experiment is the flow measurement test bench. Now, I would like to explain the procedure. First, turn on the main switch and the pump. Then, open the flow control valve. Open the gate valve until it reaches the maximum opening level. After that, close the gate valve slowly until the reading of the rotameter reaches 200 liters per hour. Next, connect the manometer tube to the inlet and the outlet of the device. After that, connect both tubes to the manometer. Slowly open the gate valve until the level water in the manometer tube changes. Observe the changes in water level in each tube. Then, close the gate valve when the reading of H1 is at maximum and H2 is at minimum level. Record the data of the different values of H1 and H2. For the next reading, reduce the flow rate with 100 liters per hour decrements for each step until the reading of the rotameter reaches a minimum of 200 liters per hour. Record each change at the manometer tube. Fully close the gate valve after finish recorded. Finally, switch off the pump and the main switch. Then, change the device for the next experiment. Repeat the same procedure for nozzle and venturi.
The next part will be result and discussion of this experiment. I'll present about the result. The raw data that we obtained from this experiment are readings of rotameter, volume of water collected, time, and also the height of manometer. The first case is nozzle. The internal cross-sectional area of pipe, which is A1, is 3.386 times 10 to the power of negative 4 meters squared, as stated in this diagram. As we can see from this diagram, the diameter of the opening is 40 mm. Therefore, by using the formula of pi r squared, we can get the value of A2, which is cross-sectional area of the opening. By substituting 40 over 2 as radius, we can get that A2 is equal to 1.539 times 10 to the power of negative 4 meters squared. Next, we need to calculate the value of actual flow rate measured from this experiment. Since the unit of volume of water collected is in liter, we need to convert it to meter cube first. For example, to calculate the actual flow rate of first reading, we will use 3 divided by 1000 and divide with 14 seconds. Then, we will get actual flow rate equals to 0.2143 times 10 to the power of negative 3 meter cube per second. To calculate the value of theoretical flow rate, we will need this formula. By using the first reading, we will substitute the value of A2, H1, H2, and A1 into this formula, whereas G is gravity constant with the value of 9.81. After substituting all value, we will get theoretical flow rate, which is 0.4316 times 10 to the power of negative 3 meter cube per second. For coefficient of discharge, we will use this formula, which is value of actual flow rate divided by theoretical flow rate. Lastly, we will use H1 minus H2 to obtain the value of delta H and square root the value to get square root delta H. Same goes to orifice plate. The value of A1 is 3.386 times 10 to the power of negative 4 meters squared, whereas the area of orifice plate can be obtained from this diagram. As we can see here, the diameter is 18.5 mm. Therefore, after substituting 18.5 over 2 as radius, we can get that A2 is equal to 2.688 times 10 to the power of negative 4 meters squared. After that, we will use the previous method to calculate the value of other results. For the third case, which is 1 meter, the value of A1 is the same as well, which is 3.386 times 10 to the power of negative 4 meters squared. For the value of A2, which is the rapidly converging section, we can obtain this value directly from this diagram, which is the A3. The value is 8.46 times 10 to the power of negative 5 meters squared. Next, we will use back the same method to solve for other value.
Hi, I will start the presentation on discuss the differences on water level, H1 minus H2 in manometer with different types of flow meter, which is nozzle, orifice, and ventrimeter, and then relate with pressure losses. Here is the graph of flow rate actual versus delta H for nozzle. Difference on water level of flow meter is directly proportional with flow rate. Throughout the experiment, it was found that as the differences on water level of flow meter increased, the flow rate and the velocity will increase, hence the pressure will decrease. And this proof with the Bernoulli equation shown. For the nozzle, the manometer the water level increased critically until at a point it continues increase gradually until the end. Next is the graph of Q actual versus delta H for orifice. For orifice plate, the trend of manometer water level is unstable. The manometer water level alternately increases gradually and drastically. This is due to the pressure tapping points placed at the side of the plate at a specific distance. Orifice causes a flow restriction and then produce a pressure drop from one side in the hole to the other. Make the amount of pressure difference is proportional to the flow of fluid to the hole. Next is the graph of log Q actual versus log delta H for ventrimeter. For the ventrimeter, the manometer water level increased in stable trend until of the halfway, and then it will increase drastically. As the differences on water level H1 and H2 in manometer decrease, the volumetric flow rate will also decrease. And same way when it's increased, it will increase as well. On the Bernoulli equation, the pressure is inversely proportional with velocity, but vice versa with pressure losses. Pressure losses is the difference in total pressure between 2 points in a fluid carrying network. When a liquid material enters one of a piping system and leaves the other, pressure drop or pressure losses will occur. In addition, pressure losses is an inevitable occurrence in every piping system that happens due to friction, elevation change, and turbulence caused by a sudden change in direction. Higher pressure difference may drive greater flow rates. The pressure gradient establishes the direction of flow. Thus, as the flow rate increases, the pressure losses will increase as well because the Q is directly proportional with delta P. I will discuss on the differences in discharge coefficient value CD for each the flow meter, and then the ranking of flow meter according to the accuracy. Here is the graph of Q actual versus delta H for nozzle. It is a linear graph with a positive gradient and positive y-intercept. It was clearly shown that the Q actual is directly proportional to delta H, which this proves that the graph is plotted. Correct. The equation that represents the graph is Q actual equal to gradient delta H plus y-intercept. So, from the calculation shown, the discharge coefficient CD for actual flow is 1.9836 exponent negative 4, while the average CD for theoretical is 0.4931. The percentage of error for the value CD calculated is 99.96%. Next is the graph of Q actual versus delta H for RS5 plate. A linear graph with a positive gradient and positive y-intercept. It was clearly shown that the Q actual is directly proportional to delta H. Prove that the graph plotted is correct. The equation that represents the graph is a Q actual equal to gradient delta H plus y. from the calculation shown, the CD for actual is 8.8807 exponent negative 5, while the average CD for theoretical is 0.2761. Thus, the percentage of error for the value CD calculated is 99.97%. Next is the graph of log Q actual versus log delta H for battery meter. It is a linear graph with a positive gradient and y-intercept 3.3974. It was clearly shown that the log Q actual is directly proportional to log delta H. The equation that represents the graph is log Q actual gradient log delta H minus y-intercept. So, from the calculation shown, the CD for actual flow is 0.0349, while the average CD for theoretical is 0.99475. Error of CD calculated is 4.04%. Based on the result obtained from the experiment, Ventometer is the most accurate flow meter compared to others. The accuracy of Ventometer is mainly due to the percentage error, 4.04%. This illustrated that reading data we obtained during experiment is reasonable and accurate. The second most accurate is nozzle with 99.96%, and the least accurate is orifice meter, which is 99.97% error. The accuracy of the Ventometer is at plus minus 1%. While orifice have the accuracy is plus minus 2%, nozzle are the same as the orifice plate, except that the thin plate is replaced with cotton nozzle, so the accuracy of the nozzle is about plus minus 1%. Differences between theoretical and experimental value due to some errors. Thus, a verification must be taken during the experiment.
Next discussion we will be talking about is factors contributing to errors or inaccuracy in experimental data and the possible recommendation to improve the existing results. First of all, the observer's eye is not perpendicular to the scale reading, causes parallax error. To avoid this error, when taking the reading from the measurement, place the manometer slightly closer to the observer's eyes and make sure the observer's eyes are perpendicular to the scale reading to avoid parallax error. Next, there were air bubbles trapped in the tube causes an inaccuracy for the results obtained. So to avoid this error, the water valve is opened to allow the water to run first through the tube in order to make sure there is no air bubble trapped inside the tube and make sure all the tubes connect tightly. Lastly, there are some holes at the head inlet tank are stuck with dirt causes the flow of water to be slightly unsteady. To improve the existing results, ensure the apparatus that will be used in a good condition by cleaning the apparatus prior to conducting the experiment, so that a more precise data or value can be obtained. So, as a conclusion, the coefficient of discharge, which is CD, obtained for a set of flow measurement instruments, including a ventometer and an orifice meter, is checked and approved by the calculation and graphical based on the objectives of this experiment. So, that's all from us, which is from Group 6. Thank you.